Hey Dr. Horn, this is Jared Geeky. This is my submission for week 2's video problem. Let me walk you through it. So part 1 asks me to calculate molarity for N2 at 1 ATM. I know from Henry's law that C equals Kp, so I plug those in. The pressure for N2 at 1 ATM is 78%, so times that by 0.78 ATMs. That gives me 2.964 times 10 to the negative 4th molarity. Question 2 is the exact same problem setup except at 4 ATMs. So the only difference is I'm multiplying that 78% times 4 ATMs. That gives me 3.12 here. Multiply those answers together, I get 1.1856 times 10 to the negative 3rd molarity. Part 3, going from 4 ATMs to 1 ATMs, what is the volume of N2 that's released? I calculated my delta solubility. That is my answer from part 2 at 4 ATMs. This is my answer from part 1 at 1 ATM. The change in solubility is 8.892 times 10 to the negative 4th molarity. Multiply that by 5 liters to get my number of moles of N2 that is released. That gives me 4.446 times 10 to the negative 3rd moles. Then, if we keep going, I know my gas law PV equals nRT. Rearrange that to solve for V. Plug in all of my answers that I found previously, my number of moles, our gas constant, our temperature at 310 or 37 Celsius, and 3.12 ATMs for the parcel pressure. Do all that math, and that gives you 0.03627 liters or 36.27 milliliters. Now, my number of bubbles that is released. The diameter of one bubble is 1 millimeter. Radius would be 0.5 millimeters, or in scientific notation, that's what I prefer to work with. Here's our volume formula, 4/3 pi r cubed. So plug in our radius, and that gives you 5.23 times 10 negative 10th meters cubed for our volume of one bubble. Now divide that by our number of our volume that we found initially, and that gives you a final answer of 68,834 bubbles. Okay, thank you.